Alright, so I am going to show you some graphs that if you saw this in a residuals plot would be a red flag that, hey, maybe something is wrong here. Which one of the three do you think that violates? So this one is bad because that is definitely a pattern. And sometimes when you do the scatter plot, it doesn't look like that's actually happening until you switch it to your residuals plot where you turn sideways and zoom in. This means the way it is not right. We need to transform it to do something. Basically, it's a nonlinear pattern. Another bad example would be something like this. Where did I do good with my prediction in that, no context, anything? Where did I do good with my prediction? Here. Where did I do bad? Here, right? So with small x values, I did a really good job. But as my x values got bigger, I did worse. That's not good. This one is this is breaking this condition. When my x's are small, they weren't scattered much. When my x values were big, they were scattered a whole lot. So that's what this means as far as what we're looking for.
But it's scattered evenly above.
For all values of x. So these x values are not scattered much. As I get to here, they're scattered a whole lot. And that's the part you're actually checking. Now, because it's that tug of war thing, you're not looking if they're equally above and below because that happens in the background. So it's this part that actually matters. This is a cone shape. You can have a reverse cone too. This would be something like if I were predicting height from something with babies, like it would do really well, but as the babies got older, maybe that prediction that I had would change. I might not use all this. I might not use all four. Let's say our y is test grades. And my residuals went from negative 50 to 50. If I'm missing what I'm predicting their grade to be by 50 points, give or take, that's probably not very helpful. Hello? That's fine. Yes. Yes. Thank you. See down. Yeah. Probably not. So do you have any questions on what the things that you're looking for violations of residual plot? I know that when I write it at first, you're like, I don't really know what I'm looking for, but hopefully seeing issues. I'm not going to give you one. For this class, doesn't get into the point where it's like, that could be a pattern, that might not be. I don't know. It's going to be something like, there's a big issue, so don't use it. Or there's something very obvious, so don't use it. The one that we did is actually probably getting close to not being scattered equally above and below zero for all values of x, but that's because we only put 6 dots up there. If I had one more dot like over here or something, you wouldn't even consider that. So it's just because we had so few actual values there. All right, what is x bar? What is x bar? I am now talking about coordinates. What is x bar? This should not be hard. This is just something I haven't asked before. What is y bar? So there is a coordinate that can be x bar, y bar, which is just the mean of our x's where that intersects with the mean of our y's, right? This is always on a least squared regression line. Which should make sense because least squared regression line is finding that middle of all the points. So the average this way and the average this way, if I follow that to there, it should fall on that line itself. So let's kind of go back and see if that fit with ours. So up here, what is x bar? So where are my x's? Where? Where are my x's?
41 times this one.
List one, how do I get to it? How do I find my x bar? One variable stats of list one. And you get an x bar of what?
79.
Point what?
5.
What is my, where do I find y bar? One variable stats of list two, and you get what?
85 and 230.
So let's see if that ended up being on ours. So 79.5 is right here. 85.6. Which fell exactly on our line. That should be the dead center of your line. This point should always be the dead center of your line. That's the center of these, the center of these. Call it.
Dead center of our line would be like 81.
Well, okay, it's not the dead center visually because your means work differently. But it is on the line in the center, depending on where it's pulled. Alright, so basically, as things change, you can kind of look at that as a pivot point. That would change too, but in general that makes sense to look at it as a pivot point. Alright, so outlier. In general, what does the word outlier mean? It's uncharacteristic from the rest of them. Well, that shouldn't apply any different when we're dealing with a graph. It's an observation that lies outside of the overall pattern of the other observations. That's not very specific. Now, is that an outlier? Is this near the rest of them? Or is this doing what the rest of them are doing?
Yeah.
But does that look like an outlier? If I didn't bring up anything today and I said, is that an outlier, would you say yes or no? Yes, right, that's an outlier. Influential point is what you're starting to think about when you started to tell me, I don't think that one is an outlier. So if removing that one point would greatly change the result.
What is that?
Oh,
yeah.
So, in the one that I just drew, I could draw a least squared regression line through that. Let's say I now remove this point. What happened to my least squared regression line? Nothing. So, because I did that and nothing happened, it is just an outlier and not also an influential point. I'm going to draw, I guess, 4 graphs right there. So as far as spacing wise.
We're not drawing our residual graph.
No, you're just drawing this. Now, can you tell which one I'm trying to draw as an outlier? Now, it helps to understand that the point x bar y bar is on the graph to do this. Now, if I take that point out, is x bar and y bar going to change? I mean, it's going to change a little bit, right? I mean, so it's not an exact science, so that's why this is, but it should make sense.
But how will we know if it will change or not?
I mean, removing a number that's not here, like, here are my y's.
Mm-hmm.
If I don't have this one, is the average of these going to be different than the average of these?
Probably, right?
Yeah, I mean, it's going to change a little bit.
So, because isn't that
Hello? That's fine. Okay, thank you. Bye. Bryce, then you gotta go to Downs.
I'll be fine with it.
Yeah, it didn't take very long, did it?
He just told me to come back after class.
Okay. The way I think about this one is pretend there is a rubber band connecting that point, and it is physically holding up the line. And I want you to draw that on there. So pretend that there is a rubber band that is pulling as hard as it can to hold that line where it is. So I am pulling to influence it my way. Removing that dot is like that rubber band snaps. So if I was pulling, it helps to think about your pivot point being like about where that x bar, y bar is. So if I am getting pulled this way really, really hard, all of a sudden what's going to happen to that line when it reacts? It's going to do this. You see like where my pivot is in the middle? So it's going to actually go this way, not just this. It's that on this pivot, it adjusts. So, and these points should be the same, but I don't care if they're exactly the same. You should be able to tell that it's going to end up more like this. And we're kind of exaggerating right now, but I want to get the point across. Which means that our y-intercept did what? How? But our slope did what? There might be textbooks out there that talk about a specific way where if this happens, this is exactly what's going to happen every time. But if there is, number one, I haven't seen it, and number two, it doesn't make sense to me to try to memorize that.
Wait, so is the rubber band one an outlier?
So when I took this out, did it change things? Yes. So is it an influential point? Yes. So outlier, influential point. Blank is always a blank. What? Influential point is always an outlier. Is an outlier always an influential point? No.
Are you going to do an example of an outlier that's not an influential point?
It's this one. But now I want to do another example here So it's always going to change based on what your slope was, whether it was positive, negative, where the point was. It could be on the bottom, it could be on the top. So I'm just going to pick another one. And this is why I don't like to think about it as a rule. I like to think about actually thinking through what happens.
Is this one related to the top two?
This is the second example. So if it is pulling it this way, when that rubber band snaps, now what's going to happen? What's going to happen to my y-intercept? It's going to decrease. What's going to happen to my slope? And I'm exaggerating to show you what's going on there. I'm not worried about what my points actually were. So I can pull from any of my four corners. I could have an outlier of influence point here, 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 or here. My slope can be positive, my slope can be negative, my slope can be 0. So don't think of this as a rule. Think of this as actually think about what's going on and it should make sense. Some people call this, instead of the slope increasing, they say the slope is steeper, because then when they go to switching from negative, that doesn't get confusing. They can just talk about it as steeper or less steep. And that's fine too. Because when you start going to negatives and it flattens out, that doesn't mean it's less, that means it's less steep.
And okay, and does it kind of matter if it's on like the more right side of the line or like the left?
So that's why if you can think through like this, what goes on, you can think about it in any scenario. Okay, extrapolation. I mentioned this the other day. Does anybody remember when I said the word extrapolation? It didn't work well because my guess was bad. Why was my guess bad? What was I using my data to estimate? If I am dealing with the height and weight of 4-year-olds, and my whole graph is based on that, and it does a really good job of it, and now I try to predict it with a 17-year-old, why is that bad? Because I'm trying to estimate a value that is where?
Very far.
Very far from. Oh, I said it.
What context are we talking about?
Just in general. So, the test rates thing. What if all of our test averages were between like 69 and 90s? So if I all of a sudden had somebody who had a test average of like a 12, this line might not work. So that would be extrapolation, is using your data to estimate a value way outside of your X values. Now, we deal with extrapolation a lot, and I'm going to ask you to do extrapolation, but I'm not going to tell you it's extrapolation, and we did it yesterday, 2 days ago. What is something we did 2 days ago that actually was extrapolation? And it will be often.
Y-intercept.
The y-intercept. A lot of times the x of 0 is going to be way outside of all the rest of our x's, which is extrapolation. Now, there can be examples where 0 does fall around the values we were dealing with, and that's fine too. I'm going to talk about this again, but I need to talk about this right now. This is a Minitab output. Minitab is a computer software thing. This deals with the problem we just did. You are going to be given information, and instead of giving all of the numbers, like all of the different values of the scores, I'm going to give you this and tell you to make up your draw line, figure out all the information that I did, like from the Monopoly. Here, that's your what? That is your least squared regression line. We usually write it as what equals something.
Y hat.
Least squared regression equation. Y hat equals. So it just puts the value in context instead of a y hat. So test would be the what? The x value. Now we've got some things down here. We've got predictor, we've got coefficient. Does anybody think they know what SE stands for? Standard error. We've dealt with that before. We've got a T, we've got a P. We don't talk about much of this chapter. Out of all of these numbers, which looks like something that we dealt with? We just dealt with. How many of these numbers looks like something we just talked about? Which numbers?
32.
This is my what? Which is your what? Y-intercept. Does your y-intercept change?
When?
If I plug in a value, does my y-intercept change?
No.
Because that is a what? It literally always says the word constant there. So what goes here beside of constant is always going to be your, what did you just say? Your y-intercept. Now, test, is that context specific?
Yeah.
We were dealing with test averages. I just put it in as one word. So this one word is talking about my what? The what of my problem. What literally goes beside of your x in our equation? Does anything else on that whole page look like something we've talked about? And does it say r? So that's r squared. Well, we have an r squared and an r squared. This is adjusted. Have we ever talked about an r squared adjusted? Well, then we're probably not going to talk about it. The other things on this page are things from chapter 12 that we don't need to talk about yet.
What about our R? It gives us R. So we just square it.
How do you find r?
Square root.
It's the square root, and I'm going to talk about this again. But then I have to know whether or not it's what.
Positive.
And how can I tell that r is positive or negative? So the sign of this with the square root of this. So I would, like on a test, I would give you output and not give you this equation, and then ask you what the equation is. And you just look at, okay, well, that's my slope, that's my y-intercept, so that's how to figure out what it is. You just have to know how to read this, that's it. Yeah.
Why is in the equation it says 0.67 and then this over says 0.067?
This one is, they do it, are you talking about this? Oh, I typed it and I wasn't paying attention. Put that in yours, I typed it and typed the 0 wrong. Thank you. And then it rounds for some reason up here, but it doesn't down here. So if you're having to type it in something, use the one that's not rounded, obviously the one that's not.